I know I do the record thing a lot, like stop and re-record, but again, YouTube has this thing where if it's longer than 15 minutes, it won't upload. So we're going to do this one now, okay? This example. Okay, so here's our second example of the AC method. Again, we want to factor this. Now, looking at this, we can see that we can definitely apply the AC method, right? How do we know that? Because we have 3 terms and it's degree 2, right? In that first example, we had 3 terms, but it was not degree 2, so we had to try something else. Although once we first took out the GCF, then we were good. But it's good to take out the GCF. Notice that there's a constant term here. So you can't factor out x at all. So we just take that m to be 0. You know, in the greatest common, in the GCF. Okay, so now what do? We want to know, can we take something out from the coefficients and the constant term? In other words, we're looking for that b, and we have to consider the factors. So looking at these 3, okay, and you might have been able to tell without listing the factors, I don't know, so, but that's okay if you needed to list them, as I did. You can, hopefully you can see that the greatest common factor is 2. Okay? The greatest common factor of the numbers here is just 2. So we have m is 0, b is our 2, and because of that, our GCF is 2. So in other words, we can really only factor out 2 so far. Okay, so we do that. And this is what we do. Okay. Right, so just like before, we've done many times, we have 2 in front, 2's down here. We have 2 up here, right? When you divide, you do division into each wonderful term here. Doing so, this is what we get. So what do we do now? Well, now we have to apply the AC. Now we really have to factor this thing. So we apply the rest of the AC method to this thing. Okay, so we have to factor this thing. Now, I didn't list what A, B, and C are in the notes, but hopefully you can see that we can take A to be, A is going to be our 8, and B is negative 17, and C is 9. I mean, just by comparing the two, hopefully you can see that. So because of that, what happens is we calculate 8 times 9, which is 72, and we want 2 numbers whose product is 72, and the sum is negative 17. So again, here, you know what? Let me use that really fun pen. Change the color a bit. That doesn't matter. So in other words, again, our A is 8, C is 9, and that's all I'm trying to say here. So by the AC method, we have to calculate 8 times 9, and that's what we're doing here. And that's just 72. So we want 2 numbers whose product is 72. The sum has to be minus 17. Don't forget the minus sign. I've had students in the past forget to do the minus sign, forget to include the minus sign. Okay? It's important. Okay. Well, it looks like 8 and 9 would do that, right? Except 8 and 9 added together is not negative 17, right? I mean, their product is 72, of course, but the sum is not 17, excuse me, negative 17, it's 17. So 8 and 9 would not go in the blanks. That's what I'm saying here. But you could probably see what's really close. You can see that we're close though, right? Instead of, we want negative 17, not 17, but what can we do? We negate. In other words, 8 and 9 aren't going to work. Their negatives will. And it's just easy, and hopefully it's easy to see that negative 8 times negative 9 is still 72. You know, just sap and sun rules. Okay, that's good. So as before, what are we going to do? We're going to replace negative 17, right? Here, let me go back. We're going to replace negative 17 here with negative 8 minus 9. Actually, sorry, negative 8 plus negative 9. I mean, putting in negative 8 minus 9, it's not wrong, but when you form the two groups, you could run into trouble, so to say. You have to be careful, that is. So in other words, we have this negative 17. Let's take it out. Okay, so we have negative 17 here, right? That is going to become, let me show the work. Let me see. So we have negative 17, right? That's equal to negative 8 plus negative 9. And then it's just like on the other slide, okay? When you put an x here, right? This is what we're doing. I'm trying to get through the example, right? We have negative 17 is negative 8 plus negative 9. And then if you put an x next to it, we're going to have it over here as well. And then, just like the other example, we're going to distribute. And that's how we get this. That's how we get that. So what we do is we apply factor by grouping to this polynomial. And if you had, instead of plus here, you just had negative 8 minus 9, this addition symbol would not be here or here. And it's not wrong, but when we do factor by grouping, you do have to be careful. Now, I hope everyone can see that the GCF of this thing is just 1. You might have to think about that a bit. It's not that hard to see, though, actually. But let me just keep going, because I really want to finish this exam. Oh, of course, then it appears there. Okay, came up at the wrong spot. Let me just erase that. Oh, for goodness sakes. Okay, my fault. I had the animations in the wrong order, so this is what I was trying to say. Okay, all right. I don't know how I missed that. Anyway, but again, I did put it here. Basically, there's a non-zero constant term. Okay, and that's why the m is 0. And also, hopefully, it's easy to see that 8 and 9 have only a common factor of 1, and that's really why our b is 1. I mean, I know we have negative 8 and negative 9 here, but remember, we're looking at the common factor among all the numbers. So the only possible factor in common with all of them is 1, which is how we get this. And now we can form those two groups. Okay. So let me keep going. This is what we had. And now we just have to factor each of these two groups. That's actually pretty easy. I mean, here, for instance, hopefully you can see the GCF, what it is. I mean, clearly the smallest exponent of x is 1. So our m is going to be 1 there. And the greatest common factor of the coefficients, 8 and negative 8, it's just 8 itself. So because of that, the greatest common factor of 8 and 8, is 8. And so because of that, here, the GCF is 8 times x. So what do? Factor it. And when we factor it, we get this. Okay, let me just pause it because I have to get the recording.